Good morning, everybody. It is 8:40 in the morning. You got about 5 more minutes before... Wait, no, nothing happens at 8:45. Oh, yeah, that's when school starts, huh? Ha! We've only been out of school for 4 days, and Olivares already is forgetting a lot of things. Anywho, I'm playing music in the background. I used to do that in the classroom, so I kind of want to keep the, rhythm going. This is a 50s hits playlist, okay, from Spotify. Surprisingly, I've been getting really into like 1950s not classical music, but just like hits. Because you'd be surprised, a lot of the music gets recycled, right? Hits from the 50s get recycled into like new mixes in today's music. So you might listen to some songs, you'd be like, oh, I've heard of that song before. I didn't know it was an old song. But anywho, today we're going to be looking at Unit 7, Lesson 8, combining bases. So we're going to be multiplying expressions with different bases, okay? And if you haven't had breakfast, please have some breakfast. I'm pretty hungry right now, but nobody has huevos. All right, so 5 to the third times 2 to the third. That's 5 times 5 times 5 times 2 times 2 times 2. 5 times 5 times 5 is 125 times 8 is 1,000. 10 to the third is 10 times 10 times 10, which is just going to be 1,000 because there's 3 zeros. I think I said 10,000 here. I meant to say 1,000. Nobody gets a pizza or food. Oh, notice how they're the same. 1,000, 1,000. Huh. That makes me think if 5 to the third times 2 to the third is the same thing as 10 to the third. I don't know. We'll see. Oh, look. No. Is this Elvis Presley? Nah, homie. I don't like the song. I know the song, but I don't like it. Alright. So, if you look at the expression here, no. If you look, 5 to the third times 2 to the third, well, that's just 5 times 5 times 5 times 5. 2 times 2 times 2. And then notice how you can change the order. It's multiplication, so you can change the order, right? You can do 2 times 5. And notice how 2 times 5 is just 10. And then, similarly, 10 times 10 times 10 is just 10 to the third. But also, 5 times 2 is 10. Maybe that's how they get the 10 there, right? Because down here, 3 times 7 is 21. So let's see if this works. By definition, this is, what is it? 3 times 3, 7 times 7, which we can change it to 3 times 7, 3 times 7, which is 21 times 21. Yeah, that seems to work. All right, let's conserve the space. So we have 2 times 2 times 2 times 2. Okay, I won't. 3 times 3 times 3 times 3. So we can change the order and have 2 times 3, 2 times 3, ... Yakety yak! Don't come back. So this is going to be 6 times 6 times 6 times 6, which is 6 to the 4th. And 2 times 3 is 6. And then there's a power of 4, power of 4, power of 4. Huh. Oh, now we got to go backwards. 15. Well, what times what equals 15? 5 times 3, right? So this is 15 times 15 times 15, which is 5 times 3, 5 times 3, 5 times 3, which makes me think it's going to be 5 times 5 times 5 times 3 times 3 times 3. So I think this is going to be 5 to the third times 3 to the third. And I don't actually think, I know this is true. Oh God, there's a lot of work. Okay, what times what equals 30? Yes, 1 times 30, 2 times 15, 5 times 6, and then there's also 3 times 10. So let's do 3 times 10, okay? You can also do 5 times 6 if you want. I'm gonna tell you straight up. 3 times 10. And then what's the exponent? 4. And the reason is 30 times 30 times 30 times 30 is 3 times 10. How many times? 4 times. Okay? So that's going to be 3 to the 4th times 10 to the 4th. That's going to be right here. 2 times 2 times 2 times 2 times x times x times x. What do they want us to do here? Oh, they want us to write it in one single exponent. So it's going to be 2x times 2x times 2x times 2x, which is 2x to the 4th. This finna, ooh, how many? Oh, that's going to be A. How many times? N times. Times how many times? N times. So how many ABs are we going to have? N times. So it's going to be AB to the nth power. Bro. Ooh, what's this song called? I Can't Help Myself. Hey, some of you might recognize this song because it's a Spanish version of it. I raised up the volume. I increased it by 50%. From 10 to 15. So, seven times 5 is 35, times 2 is 70. En un café donde yo la vi llorar. I think the Spanish version of this song is called En un café. There's 4 70s. What happens if neither the exponent nor the bases are the same? Can you write 2 to the 3rd times 3 to the 4th with a single exponent? Nope. It would be, well, let's see, 2 times 2 times 2 times 3 times 3 times 3 times 3. This can be written as 2 times 3, that's 6 to the 3rd power, and then times 3. That's why you can't write it with a single exponent. I am. How many ways can you make 3,600? Big oof. Boardwalk. Alright, don't worry about this one then. But if you want to challenge yourselves, how can you break apart 3,600? Like, using exponents, right? Because if actually, let me just show you. I'm not gonna have y'all do it, but you can. Let me do. So this is called a factor tree. That's supposed to be a 6. So 3,600 is 36 times 100. 36 can be broken up as 6 times 6. 100 can be broken up as 10 times 10. This is 3 times 2. 3 times 2. 5 times 2. 5 times 2. What song is this? I don't like it. Nope. Ooh. This look good. That's a banger right here. So, when the night has come and the night is on, on the moon, and you only should I be. This is called I Won't Be Afraid. No, I won't be afraid. Just as long as you stand by me. So darling, darling, stand. So this is called the prime factorization. That's when you break apart a number into all of the small numbers and then you write it using exponents. It's actually really fun, and you'd be surprised how important this is in later maths. Okay? You have probably noticed that when you square an odd number, you get another odd number. And when you square an even number, you get another even number. Here's a way to expand the concept of odd and even for the number 3. Every integer is either divisible by 3, 1 more than a multiple of 3, or 1 less than a multiple of 3. I ain't gonna lie, I learned this in number theory, which is a college level math class. So I think it's really cool that you are getting introduced to this really young. Examples of numbers that are 1 more, so that means 1 more than a multiple of 3 are 4, 7, and 25. Give 3 more examples. So the way you can find these is, right, multiples of 3 are 3, 6, 9, 12, 15, 18, 21, ... So if you just add 1 more to these numbers, 4, 7, 10, 13, 16, 19, 22, these are all 1 more. And similarly, if you were to subtract 1, those would be numbers that are 1 less than a multiple of 3. So 2, 5, 8, 11, 14, 17, 20. These are all 1 less. Ooh. Do you think it's true that when you square a number that is a multiple of 3, your answer will still be a multiple of 3? So I'm going to prove it to y'all right now. I'm going to prove to you that a square of a multiple of 3 is a multiple of 3. This is what I had to do when I was in college. Like once you do calculus, which is literally just writing numbers down and using calculators to crunch stuff, then you go into like the theory of numbers. That's when you really start using mathematical logic and thought to prove stuff. And that's what real math is. Real math is not using calculators to find like 3 times 7. Real math is proving why 3 times 7 is 21. That's the whole reason why we're having y'all justify your answers. This takes me back to when we were in class. Like, y'all would give me the answers, and I'm like, no, I don't care about the answer. I want to hear what you think. That's where the real math is happening. That's where the real logic is. Anyways, enough talking. So, a number that is a multiple of 3 technically can be written. Let me just use the letter M, because I like the letter M for obvious reasons. A number that's a multiple of 3 can be written as 3m, where m is a whole number, right? Like 1, 2, 3, 4. So when you multiply by 3, obviously it's a multiple of 3. So squaring 3m means you multiply it by itself. So this right here is a perfect square. Something like 9 or 16 or 25 or 36, right? If you multiply it by itself, it's a perfect square. 3m times 3m is 3 times 3 times m times m. This right here is another number. Whatever m is, right? M is a whole number. We already know that, right? We established that right here. M is a whole number. So when you multiply m by itself, when you multiply n by itself and then you triple it, it's still another number. And you're still going to multiply it by 3, which is the literal definition of a multiple of 3. So to answer your question, I'm not even going to check my answers. Do you think it's true when you square a number? No. Do you think it's true when you square a number that is a multiple of 3, your answer will still be a multiple of 3? Yep, we just saw it right now. Now, if you can't do this right now, that's perfectly fine. I was 25 years old. Okay, maybe I'm lying. I was 23 when I was doing this type of math right here. And that's talking about somebody who has always liked math, okay? Now, if you were kind of able to follow along, that's awesome, okay? Like I said, math comes down to being able to prove stuff. This type of stuff right here, okay? The math we're doing right now is to prep y'all for the real world, surprisingly. So, before we look at the homework, the lesson summary, what you should have gotten out of today is that if you have 2 times 5 and you're raising it to the 3rd power, you can technically distribute the exponent and write this as 2 to the 3rd times 5 to the 3rd. You can do that, right? Because it's all multiplication. Similarly, you can go backwards. If you have 2 to the 7th times 5 to the 7th, you can multiply the 2 and the 5 to get 10, and then just write it with a single exponent of 7. This is what they're talking about. Okay, let's do some homework. Not a lot of homework. Damn it. Select all or true statements. Ooh, so is this true? If we have the same base and we're multiplying, do we add the exponents? Oui. That means yes in French. We have different bases, but we have the same exponent. 8 times 9 is 72. I think this is true, yes. Eight times 9 is 72. Okay, but we're supposed to keep the same exponent. This is false. Oh, this is hella wrong. Right? You could take a look. They have the same base, so you should be adding the exponents. And they do add the exponents, but they also multiply the bases. Wrong. I don't like the song. Damn, I remember this song. They used to sell these little like cheap toys at the Pulga, and it had the song. It was like a little dog playing it. Do you love me? Do you love me? Okay, so we're gonna distribute this. 3 to the 4th times 5 to the 4th times 2 to the 5th times 3 to the 5th. Working out, hey, working out, baby, working. I'm gonna use different colors for the 3s. Do the twist. Okay, so how many 3s do we have? 4 plus 5 is 9. And you're looking like this. How many 5s do we have? 11. 2 to the 5th. 2 to the 7th. So how many 2s do we have? 12. So x equals 12. Y equals 9, and then Z equals 11. That was kind of fun. Han found a way to compute complicated expressions more easily. Since 2 times 5 is equal to 10, he looks for pairings of 2 and 5s that he knows equal 10. For example, 3 times 2 to the 4th times 5 to the 5th is equal to 3. Okay, so he broke up 5 to the 5th as 5 to the 4th times 5. And then he knows that this is just 10 to the 4th. That's what he did. And then 3 times 5 is 15. 10 to the 4th is 4 zeros. And then times 15 would be that. Use Han's technique to compute the following. Okay. Remember, what we want is groups of 2 and 5. So expanding this is 2 to the 4th times 5 times 3 to the 3rd times 5 to the 3rd. Right, because this has an exponent of 1 times 3 to the 3rd. This is going to be 10 to the 4th times 3 to the 3rd. 10 to the 4th. Well, this is going to be 27. And then there's 4 zeros. I don't know this song. Oh, I've heard this song before. I like it. Okay. Well, this is gonna be fun. Here, let's do this. 2 to the 3rd times 5 squared. I'm just rewriting it. Times, and then we're gonna distribute this. Distribute this. And then what can we do with the 3 squares? Yep, we can cancel. So then, let's take a look at the 2's. Right, let me just erase that. 2 here, 2 here. So we can write this as 2 to the 5th times. Now let's look at the 5's. Just a little bit longer. Okay. There's one more 2 than there is a 5. So I can write 2 times 2 to the 4th times 5 to the 4th times 3 squared. This right here, that's going to be 10 to the 4th, right? Because 2 times 5 is 10. And so we are left with, let me use green with this. Now 3 times 3 is 9. Times 2 is 18. So this is 18 followed by 4 zeros. Oh, lollipop. The cost of cheese at 3 stores is a function of the weight of the cheese. So if you want to know the price of a cheese, you need to know how much it weighs, which makes sense. The cheese is not prepackaged, so a customer can buy any amount of cheese. Ooh, let's get some queso fresco. Store A sells cheese for $8 per pound. So the slope is 8. Store B sells the same cheese for $8 per pound, and a customer has a coupon for $5 off the total purchase at the store. Okay, so I think I see where this is going. Okay, so the slope here is B with a $5 coupon. And then store C is an online store. Okay, first of all, never buy cheese from an online store. Unless it's Parmesan. Because actually, the only place you can buy legit Parmesan, like real authentic Parmesan, is from Italy. Everything else is fake. Fake news. Store C is an online store selling the same cheese at $C per pound, but with a $10 delivery. Okay. And I think this graph shows the price functions for stores A, B, and C. Okay, Okay, this is actually really straightforward. So, here, how do I want to do this? Okay, so the equation for the first one is just going to be y equals a times x. We don't have a starting value because, we're not getting charged. Oh, that's a good song also. We're not getting charged to deliver, and we're not saving any money with a coupon. So y equals ax. This means it's going to be crossing here at 0. So the equation for this one is going to be y equals b times x, but is it going to be plus 5 or minus 5? Think about it. You're saving $5. So will it cost you $5 more or $5 less? You got it. It's $5 less. So we're looking for the equation here where the y-intercept or the starting value is below the x-axis. And sure enough, it's k. Will it be plus 10 or minus 10? Are you getting charged $10 more, or is it going to be $10 less? Yup, $10 more. And sure enough, look, $10 starting value. Okay, so how much does each store charge for the cheese per pound? Okay, I gotta stop. So we gotta find the slopes. We gotta find out what A equals, what B equals, and what C equals. Okay, so if we take a look at, let's take a look at this one here. Here's a little point, and if we go along the line, I'm gonna stop at this particular point because they both cross the axes. So the price difference here is 20. Okay. And the x-axis changes by 5. So what's 20 divided by 5? 4, right? $4 per pound. Now it's the blue graph, so that's C. Per pound. And you're going to do the same thing for the red one and the green one. So this one crosses at the origin, follow the line until it crosses at a specific point, like right here. Now to make things easier on the eyes, I'm going to go ahead and draw the triangle the other way, okay? Like this. It's the same idea though. So the rise is, let's see, 10, 20, and the run is 5 again. Wait, that doesn't make sense. Oh, okay, I found a mistake. This doesn't count for the mistake if you're trying to get free food from me, because I found the mistake, okay? So, anyways, let's finish off this one and then I'll explain what the mistake is. So, it went up by 20. It's 5 cheeses. It's the red one, right? So, that's 20 divided by 5. That's $4 per pound. The red one is the first one. So, it's $4 per pound. Now, the mistake was the first triangle I drew. Yes, it's being divided by 5, but this is 10 right here, and this is only 5. I didn't go up by 20. So this should actually be right here. This should be a 15. So it should be 15 divided by 5, which makes this $3 per pound. And now this green one, actually I'm gonna use the green one. Charlie Brown. I don't like the song. No. Alright. Y'all know this song. Here, the rise is 20, but the change in X is only 4. Honey, honey, dun, 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 dun. 20 divided by 4 is $5 a pound. So looking at store B, the coupon is how much? The coupon is $5. So how many pounds can you get for free? 1 pound. Which store has the lowest price for half a pound of cheese? So you're looking, here's a pound of cheese, half a pound. No. You're checking to see which one has the lowest cost. And sure enough, it's line L. I think it's store A, right? Actually, you can make an argument and say it's store B. Because with store B, right, half a pound, since it's $5, half a pound would be $2.50, but then you get a $5 coupon. That's negative $2.50. Does that mean they give you $2.50 back? I don't know. If a customer wants to buy 5 pounds of cheese for a party, which store has the lowest price, right? So here's 5. Oh, actually, there's 2 different stores, L and K. So that's not the blue one. Store A or B. You can use either. So, but if you want to use store C, because remember, store C charges the cheapest pounds, $3 per pound. How many pounds would you have to buy before it's the cheapest option? And that's this line right here. Right here. How many pounds is that? 10 pounds. So if you're trying to stock up, on toilet paper and some cheese for people that are lactose intolerant, you finna need to buy 10 pounds of cheese. Well, I hope you enjoyed this video. We got music playing, so maybe I can start doing that. I'll change things up a bit. You see.